Hey everyone, thank you for coming to this session. My name is Ravi Devineni. I'm a Senior Director of Engineering for a team that leads Cloud and DevOps at Northwestern Mutual. I'm honored to be joined by Bobbi Wenzler, who's our lead product manager. We're here to talk about risks in supply chain and how to automate the idea of creating trust into CI/CD pipelines. Thanks to PlatformCon for giving us the opportunity to share some of our ideas here. A little bit about our company. Northwestern Mutual is a financial services company headquartered in Milwaukee, Wisconsin. We started as a mutual in 1857, established for the benefit of our policy owners. 165 years later, today we're a Fortune 90 company with more than 4.9 million clients. Northwestern Mutual is the largest direct provider of individual life insurance in the US. We have high degrees of customer satisfaction with 97% of our policy owners staying year after year. The agenda for today, we're going to talk about what supply chain is and what security risks it can pose to an organization. And then Bobby will talk about some of the ways we have used to bring automation to address this problem. Software supply chain. Essentially, software applications are made of a lot of different components. The code that we write, obviously, that is only one part though. There are multiple libraries that you use which have a web of complex dependencies among each other. These are basically open source components, right? And then there are a lot of different tools and infrastructure that we use to build and deploy application. Basically, everything that we use to build and deploy software, that's your software supply chain. We're going to specifically talk about open source components only here in this talk. Now, there are a lot of benefits for using open source components in your software. They're listed on the right. Basically, it makes your job easier and helps you not reinvent the wheel, right? You can focus on your business logic while all of the standard components are reused. But with a lot of these benefits come some major pitfalls as well. So the biggest problem with using open source is the security risks it poses. There are thousands of vulnerabilities that exist in open source software. A recent example of this is the executils that was planted as a backdoor. This was a very sophisticated social engineering attack that was multiple years in the works, and it used multiple personas as well. Fortunately, it was detected, but the damage could have been extensive since it touched essentially all Linux operating systems. SolarWinds was another one of those extensive and an expensive one supply chain attack. With a lot of these security vulnerabilities, right, the question really becomes, can we actually trust open source software? How reliable is the source? And many of these dependencies use some kind of versioning, and there's active development happening on many of these components. So the need for updates is pretty constant. So if you don't change your application, it can quickly become vulnerable. So a lot of these issues, it begs the question that is open source really free, right? Like, and what is the total cost of ownership? But it's not all bad news. There are a lot of nonprofit organizations working tirelessly to solve such problems. So we'll talk about a few solutions here, and Bobby will go into more details. So first, every company needs to know what open source software they have in use. Without that, they're flying blind. This is the inventory, not just the inventory though, but a complete line of sight into what open source is being used and where and what versions are we using, right? And how current are we with those versions? If a vulnerability gets detected in a specific version, we need to be able to exactly pinpoint what parts of the company's code base is affected. This is your blast radius. So if you don't have an open source inventory, start here first. Next, a software bill of materials is essentially a list of components that make up your software. There are various open source tools and commercial tools for generating SBOMs. Next, we need to scan for vulnerabilities that live in our ecosystem. And this scanning needs to be embedded into your CI/CD pipelines, right? With the ability to block release of a pipeline when certain high vulnerabilities are discovered. Next, you need to have your own block list, a list of components that must be blocked from entering your ecosystem. Once you have a list, you have to centralize your ingress. There basically should be only a single entry point for all of the open source dependencies from entering into your ecosystem. Then you can, if you have this list, if you have a centralized ingress, you can create a simple rule that blocks all the dependencies in your centralized ingress. Next, There's a lot of open source components, right? And not all of them are created equally. If you look at the stats, 75% of the code bases have at least one high vulnerability. 88% of the components have essentially been abandoned. In such an environment, the question really becomes, how do we pick a good open source dependency for our use? Open Source Security Foundation, OSSF, has a project called Scorecard. It's an automated tool that evaluates the component in various areas and assigns a score of 0 to 10. Some of these areas include, does the open source component use CI best practices? Or is it still maintained actively? Or does it have branch protection? Or does it have vulnerabilities? Things like that, right? If it looks at various such areas and comes up with an overall score from 0 to 10, like I said, this is a very useful tool to help us understand whether a dependency is healthy or not. Next one, with every open source component, there is a license associated with it, which basically tells you, do you want others to use or distribute or even contribute back to your project, right? For example, someone cannot legally use any part of your GitHub project in in their code, even if it is public, right? Unless you explicitly give them the right to do so. There are various kinds of licenses. There's permissive licenses, and then there's copyleft licenses, right? Within copyleft, there are strong copyleft and weak copyleft as well. Generally speaking, open source components with MIT 2.0 or Apache 2.0 or BSD, these are all generally okay to use. But there are some strong copyleft licenses such as GPL or Afro GPL 3.0 that have very, very specific conditions. So this is an area where most technologists are less familiar with the legal jargon involved here. So legal team should definitely be involved in this entire process. Next, Bobby is going to dive into how we incorporated a lot of these ideas into a single holistic solution. Bobby?
Thanks, Ravi. Now I'll talk about how NM used automation to help solve some of these gaps that Ravi spoke about. So we leveraged the OSSF scorecard, which Ravi talked about on some previous slides also. We set up a proof of concept to really understand what value this could bring to our org. And then we found out we definitely were interested in understanding the health of the dependencies from what we saw in that proof of concept. So we built out a process that not only scanned at each commit, but also at a nightly, batch process. You might be wondering, why did we build both? Well, we really wanted to ensure we were understanding what new open source was coming in with every commit. We weren't waiting till a nightly process ran. And then the nightly process also ensured if new changes were happening in those dependencies we were using and we hadn't picked them up yet, they were getting rescanned as well. We started off initially with JavaScript and Python because those came out of the box with this open source library. And then because NM has a very big footprint with Java, we added in some custom processes to pull in Java dependencies for our world. And then we also developed a custom UI to make it easier to visualize the dependency usage across our org, more of that inventory, and what a specific repo's health could be as well. As part of that, we also now have captured what version is in use for each particular repository as well. So let's get into a demo of what this looks like. So right here, you can see when you come into our open source software or OSS line of sight, we start in the project view. So I could type in a project in the search box, and when I click enter, up would pop the details about that particular repository. So you can see here our lowest scored dependency, which I've named lowest for group my project, scores a 6.4. And we tried to make a nice visual to show where your particular project was at, a target we may set in the future for our enterprise, and where you might fare amongst the other libraries in our organization to really bring some gamification to it. So with that, the lowest dependency then is listed down below along with any other ones, the version that we're using, that it's a third-party Python library. It's got an MIT license, which you heard Ravi talk about earlier in his presentation, a link to the GitHub repository, and then the score. So normally there would be a lot more listed here, but wanted to keep it simple for this presentation. But one thing I really did want to point out is that your project can only score as well as your lowest dependency. Whatever the lowest score is at large is where we think the health of your particular project is. we really wanted to ensure people were looking at where they might have work to do and remediating that to get a better score for their project. So let's go a little deeper now. If I click on my score 6.4, up would pop a little modal window, and it would give me a lot of information about what's going on with that particular dependency. Due to the speed of our presentation today, I'm not going to go deeply into all the checks, but I will talk about the ones that we want folks to pay attention to, which we've indicated with the little red warning icon. So the first one here is branch protection. You can see the branch protection is not set up optimally for this particular repo. And why we should care about that is because maybe I want to go add some malicious code. I'm a bad actor. I might not need peer review. Maybe I just need to get my merge request through one person's set of review. I also might be able to potentially force push and overwrite all the code. So really that is a concern. Definitely want to be sure that your open source is following source code management best practices, just like your own code in your company is. The next one is CI tests. So being from an org that definitely focuses a lot on CI/CD, this one's near and dear to my heart. You want to be sure that you're having testing occurring before you get into the mainline branch. You really want that fast feedback on issues or, to detect vulnerabilities before they get into your mainline branch. The next one is one of my favorites, the CII best practices. And this really is looking at a lot of other checks that are part of the OpenSSF best practice badge tiers. Some of those checks are around having an automated build process, having release notes, having versioning. So some of the core tenets of what good CI/CD should look like. So that was kind of the view of a specific project. Now more for that inventory view, let's say we have a dependency, we want to know what it looks like in our organization. I could search for, in this case, dependency. So I mocked this one up off our real UI. One of my favorite features is we show how many projects are actually using this dependency in our company. So you can see there were 59 using the dependency I looked at and mocked up here. Again, we can see the score, for the dependency, which is really nice, which you saw us just cover on the last slide. But the really cool part is if I click on that little project impact button tab. When I do that, this is where that inventory takes things to life. I can see out of those 59 projects, which ones in our actual source code management tool with links have the dependency, what version they're at. So maybe if we're worried about a specific version of this dependency, we can go out and understand where we might have potential gaps that we need to remediate. We also have what we call a project UTAN, or Universal Technology Asset Number. This is really a specific number that we use at NM to tie to assets or applications, which then would tell us more details about what that particular application is. And why this is so important is it ties to other metadata in our company, like security category. This is really understanding the risk of something. So say a lunch menu at our company is going to have a much lower risk score than an application that may support and data visible by our customers out in their homes on the internet. The other big thing we look at is top tier. So the top tier is something set at Northwestern Mutual based on our mission critical business applications. So this could be, for instance, our underwriting systems. So things we want to focus on from a data security perspective and just business criticality. So now that you've seen the OSS line of sight, what else could be possible? You could set scoring targets and customize where you want your particular organization to land. You would definitely want to gather and factor in the software bill of materials, which you heard Ravi talk about as well, into that scoring. You could use artificial intelligence to provide recommendations. You wouldn't want everyone for those 59 projects going out trying to solve the same problem. You'd probably want to shift this left into the development process and pipelines to give even faster feedback. And then you heard Ravi talk a lot about blacklists and governance. Definitely would be another thing we'd want to focus on. And at that, I'll thank you all and turn it over for any questions.